Hello, today I'm going to take you through my introduction to logarithms and their properties. Okay, so we've already talked about graphing them a little bit and how they're the inverses to exponential functions, but now I want to talk about, algebraically speaking, what are the properties with these? Before we actually talk about logarithms, I want to look at something else, and that is this Egyptian tablet that I have here. I always joke with my students telling them that they're real Egyptian hieroglyphs here, but they're not. These are obviously printed on a computer. And then my students looking at this, we've got this funny symbol right here. And so there's always a discussion, is that a bundle of sticks? Sometimes it's called bacon. You know, some students look at it and say, that looks like bacon. And you know what? I like bacon. Who doesn't like bacon? That's what I'm going to go with when we're looking at these. This is most definitely bacon, all right? And so I have over here bacon 5, 4 equals bacon 5 plus bacon 4. So this is the way I want you to look at this. Bacon is a function here. So when I got the bacon of 5 times 4, that equals bacon 5 plus bacon 4. Stay with me here, okay? If I got the bacon of 7 times 2, that equals bacon 7 plus bacon 2. So I can split that function up. Instead of saying bacon of the product of two numbers, that's the same thing as the bacon function plus the bacon function of the numbers individually. What I want you to do is look for a pattern on all of these. You should have access to this document if you're in my class. There's actually 2 pages. Make sure you're on the correct page. We're going to do both today. So pause the video. If you don't have that document, you can still, you can take a screenshot, pause it and take a screenshot there. And then you can pause and take a screenshot there and try to work this out. You can draw the bacon yourself on your own piece of paper if you don't have access to a printer. All right, pause the video and we'll go through it together. All right, I take it that you've paused the video, you've given it an attempt. Let's look at this together, because as we go through it, I think if you didn't get it, you'll be able to understand it as we go through it. So right here we have our first 2 things, kind of letting us know how these properties of bacon work out here. And I'm going to work backwards now. So if we were given bacon 7 plus bacon 2, we could change that to bacon of 7 times 2. And that's what we got right here. We got bacon 3 plus bacon 9. Well, we can change that. Do your best job drawing bacon right there. We can change that to bacon of 9 times 3. Or we can say 9 times 3 is 27, so this is bacon 27, right? It's very hard to draw bacon with a marker, so you just have to trust that that is bacon right there. And an equal sign. So bacon of 9 times 3 is bacon 27. Remember, bacon is standing for a function. We don't know what that function is, but these are the things we discover as we're looking at these hieroglyphics right here. Then we've got this right here. We've got the bacon of 6 plus something equals bacon of something times 8. So I'm going to say, you know what? If we make this a 6, we get the bacon of 6 times 8 is the same thing as bacon 6 plus bacon 8. My bacon symbol right there. Who's hungry, right? Anybody hungry for bacon right now? All right, now this is something new. This is now dividing. So when we have the bacon of 4 over 7, we can split this up into bacon 4 minus bacon 7. So I want you to take a look at this. We've gone from saying 2 things being multiplied can be split up into adding, and now we're saying 2 things being divided can be split up into subtraction. That's exactly what's going on here. We're saying dividing can be split up into subtraction. Where up here we're saying multiplication can be split up into addition. I promise that we are headed somewhere with this. It's not just all about fun breakfast foods. So we've got bacon of 4 over 7 equals bacon 4 minus bacon 7. Well, what if we said subtraction first? Well, if we had bacon of 5 minus bacon 11, we can combine that and make it the bacon of 5 over 11. Let's see if we can fill out these blanks based on that. I've got the bacon of 12 minus the bacon of something is equal to bacon something over 13. Well, this 12 coming first here, so it must be going up top. And notice we have, this should be 5 minus 11 from here. This is going to be 12 minus 13. The key is these have bacon in front of them, and so does this one. So we can expand it from bacon 12 over 13 to bacon 12 minus bacon 13, or we can condense them. We can say bacon 5 minus bacon 11 can be rewritten as just 1 bacon of 5 over 11. All right, the next one, bacon of 2 minus bacon of something equals bacon something over 3. I'm going to put that 2 up top here, and bacon 2 over 3 is the same thing as bacon 2 minus bacon 3. Next one, bacon of 6 times 8. Oh, wait a minute, we switched back to multiplication here. Let's expand that and make it, that's the same thing as bacon 6 plus bacon 8. Not a hashtag, it's bacon. Blue bacon. All right, bacon of 4 plus bacon of 4. Well, we can combine that and make that. That's the same thing as bacon 16, or bacon 4 times 4, right? Maybe you can do a better job drawing bacon than I can. If you're in my class, when I teach this in person, I actually have bacon magnets, which make it a little bit easier to do. But here I don't have small bacon magnets or pictures or anything like that. So we're just drawing them. Now the bacon of 7 minus bacon 11, I can rewrite that as bacon 7 over 11. 7 divided by 11 here. And lastly, I've got bacon of 25 over 16. That can be rewritten, if we want to, as bacon of 25 minus the bacon of 16. Order is important. Just like 25 over 16 is not the same thing as 16 over 25, bacon 25 minus bacon 16 is not the same thing as the reverse of that. You can't say that's the same thing as bacon 16 minus bacon 25. For addition and multiplication, the order doesn't matter because that goes back to the commutative property, right? But remember, subtraction and division do not commute, so the order is important. Whatever's up top goes first, and whatever's on the bottom goes second with the subtraction sign in between. So that's the first sheet there. All right, and like I said, we are headed somewhere, but before we actually connect this to our lesson today, I've got another coded sheet for you to go through here. So I want you to give this one a try. Once again, if you need to screenshot it, you can pause the video, screenshot that, or write it down. And then moving it up, this is the rest of it right here. Pause the video, give that a try, and then we'll discuss it. All right, I take it that you gave that a shot. Let's see how you did. So we're going to go through this one as well. Looking at this, now we've got something different here. We got the bacon of 2x. Actually, that's not something different, is it? It's just got a number in there with a variable. So we say, once again, if we're multiplying two things, we can split that up with addition, where we write down that function twice instead of just once. And so the bacon of 2x equals the bacon of 2 plus the bacon of x. Once again, with this variable, we can combine or condense these two. Instead of saying bacon twice, we can say, you know what? Let this be one bacon. And we're going to say it's the bacon of 5a. If you're not tired of me saying bacon, you will be by the end of this video, right? Then we've got one here where we've got three things being added up. So we've got the bacon of 7 plus the bacon of x plus the bacon of y. That's way more bacon than we need because we can write this as just bacon of 7 times x times y. Then we've got another subtraction symbol here. We've got the bacon of x minus the bacon of something equals the bacon of something over 11. So x is written first, that goes up top, and since 11's in the bottom, it's going to go in second place right there. Then we got the bacon A minus bacon B. We've got that can be condensed to saying, you know what, we've got two bacons here, we can make this one bacon and just turn that into a fraction of A over B. The bacon of n over m can be rewritten as the bacon of n minus the bacon of m. And then we've got this right here. This is where I'm saying, you know what, this is something different because now we've got the bacon of something, in this case x, raised to a power. And what does that equal? Well, that equals we're moving that 2 right here out to the front, aren't we? So that 2 goes to the front, and we can say that's the same thing. Bacon x squared is the same thing as 2 bacon x. Okay? Look and see if that's true over here. Bacon y to the fourth is the same thing as 4 bacon y. So we're taking that exponent and we're moving it out front. Likewise, we can go backwards. If we've got a number out front, we can move it to the exponent spot right there. So this is our code for doing the rest of this, all right? So if I look down here at this is not a minus sign or anything like that. That's a blank space. And so we've got a 4 right here in front of the bacon. So I can actually say, you know what? Bacon r to the fourth is the same thing as moving that 4 out front and saying 4 bacon r. Bacon t to the seventh, I can move that 7 out front and say that is the same thing as saying 7 bacon t. That's a bacon symbol. I can't draw bacon any better than that. All right, then we've got this weird thing going on. We've got bacon 3 times x squared. So I can break this up, I know, with our multiplication stuff like we did up here on the top. We can say, you know what? This can be split up into bacon 3 plus bacon x squared. So I'm basically just saying, I'm going to split it up right there. Those two things are being multiplied, so I got bacon 3 plus bacon x squared. And then, you know what? I can expand that even further by moving the 2 out front. So it becomes bacon 3 plus 2 bacon x. All right, 2 more, and then we'll say where this is all leading to if you haven't figured it out yet. You probably watched the title of the video and were able to figure it out from that. What we have here is we've got bacon 4 plus 3 bacon x, and what I'm going to do is say move that 3 up top, and I can condense this a little bit. So it becomes bacon 4, that's the first one right here, plus bacon of x cubed. So I move that 3 up top, but I can combine it even further. I've got bacon 4 plus bacon x cubed. Let's make that bacon of 4x cubed. All right? I know, that's a horrible bacon sign. Oh well. We're going to replace it with something else besides bacon, aren't we? And then lastly here, we got bacon x minus 5 bacon a. Let's move that 5 up top, and I get bacon x minus bacon a to the 5th. And I say, you know what, when it's subtraction, I can combine this into 1 bacon just by moving it from subtraction to division. That one goes up top, the x goes up top, and then a to the 5th in the bottom. So that is the same thing as saying, you know, bacon x minus 5 bacon a is the same thing as bacon of x over a to the 5th. All right? That's your results for all of our bacon hieroglyphics, because the Egyptians, I'm sure, ate lots of bacon. Maybe they did, maybe they didn't. I don't know. But all of that to be said is we can create some properties of logarithms that follow these exact same rules. So maybe you got that pretty quickly. You were able to just, not even watching the video, maybe you fast forward, you're like, you know what, I got it. I just want to check the work. And you got it right. Sometimes it's easier to look at things as bacon instead of logarithms, because logarithms for some reason just sounds like a scary word, and just doing a little picture puzzle, I think, sometimes helps students out. So these are what we're going to look at now. Instead of saying 2 bacon or bacon 2x here equals bacon 2 plus bacon x, let's look at it as a logarithm. So if I had, instead of the word bacon, I'm going to substitute it out with log, I could say the log of 2x is equal to the log of 2 plus the log of x. These are the exact same things as what we've been doing all along in today's lesson. Instead of saying bacon, I'm replacing it with the word log. Exact same thing there, just what's in that pink box there. Switched out from bacon with log. Everything you've been doing here is logarithms. And so there are 4 important logarithmic properties that we can come up with from today's lesson. The first one is this. If we have the log of A plus the log of B, that equals, notice if we're taking the log of something plus the log of something, it's equal to the log of those two numbers being multiplied, or the product of them. All right, that's the first one that we can look at. The next one is with subtraction. If I have the log of a minus the log of b, that equals the dividing these two. So it's just one logarithm, the log of a divided by b. We did that somewhere in here, like right here. Instead of saying x, we could write the word log. The log of x minus the log of 11 equals the log of x over 11. All right, so that's our second property. The next one goes into these exponential ones right here. So if I have something like the log of a raised to the power of b, then I can switch that and move that b out front and make it b times the log of a, like that. Or go vice versa with any of these. I can switch and go from a condensed form to an expanded form, the other way around. So I guess looking at it, I said there was 4 properties. There's actually only 3 that went through with this Egyptian tablet example here. For some reason I felt like there was 4, but 3 that it covered. There are more properties of logarithms, but these are the ones that we're going to focus on today. Now, I put in here the log of a plus the log of b equals the log ab. Notice that what is the base of this logarithm right here? Like if I had to write a number there, what number would I write? Well, it would be a 10, because remember, if we don't write out a base, we're talking about base 10. But really this works for any base. It could be base 4, log base 4. Now it has to be the same base all the way across, so that would have to be a 4 and that would have to be a 4, but that works. It also works when the base is e. Remember, when the base is e, we say the natural log of a plus the natural log of b is equal to the natural log of ab. So we can write out all the properties in any base we want, whether it be base e, base 10, base 4, whatever base that you feel like is necessary for what we're doing. But across the board, they have to be the same base for this to be true. I can't say base 4 here, base 10 here, and get some other base right there. There is a change of base formula that we can use, but we're not going to talk about that in this video. So for what we've got going on, it has to be the same base across the board. Let's look at what a typical problem might come out as when we're doing something like this. So this is from one of the worksheet examples that I'll take you through, but right now I'll just give you one of those examples. We have the log base 5 of 4 plus log base 5 of 3. If I want to, the directions here are to write this as a single logarithm, or I could say condense that logarithm, combine it up with the properties we know. Well, this is just like saying, remember, bacon 4 plus bacon 3 equaled bacon 4 times 3. So we could say log base 5 instead of bacon of 4 times 3. And we can go even further than that because we all know what 4 times 3 is, right? We can say that is the log base 5 of 12. And that is our answer there. Let's do another one. And like I said, I'm going to take you through this right here eventually. But right now, I just want to show you how these properties work out. Let's do this one right here. This would be... I had one in mind and then I lost it. There it is. If I had the log base 4 of 60 minus log base 4 of 4 plus log base 4 of x. And I want to condense this into a single logarithm. I still want to follow order of operations here, which means to, excuse me, add and subtract from left to right in order there. So I want to combine these two first because that makes a difference here. So combining these, I'm going to say this is the same thing as log base 4 of 60 over 4. And then, of course, we're going to bring this down. So plus log base 4 of x. And then I can combine these two. So these two work out to be log base 4, everything's same base, that's what we want, of this right here times this right here. So that gives me 60 times x over 4. You can reduce this. So 60 divided by 4 is 15, so we can say it's 15x. But make sure you're writing the base, okay? Don't forget, don't just give me log base 15 of 15x. This would be, or the log of 15x, that would be base 10, and I'd have to count points off. Make sure you write the base in there, because that makes a difference. I know that if you're in my class, I'm probably introducing you to this first before we actually talk about what a logarithm is. We know they're the inverse at this point, the inverse to an exponential function, but we haven't really talked about solving the equations or what it actually means. And so I just want to kind of show you this so we know how to manipulate logarithms. And then we're going to learn really what they are. So for right now, I just want you to get used to the properties. We're going to go over some properties. We can condense them or expand them like we did with the bacon. And so the next video I'll probably have you watch will be one just going over example after example after example until you're very comfortable with it. Okay? Let me know if you have any questions, and be sure to watch the next video, which goes over a lot of examples. Thanks for watching.